All right, in this video we're going to look at the idea of absolute convergence. And this is an extension of comparison test. So what absolute convergence says is if an improper integral of the absolute value of a function converges, then the function itself converges as well. Well, let's look at why that's true. So if I think about this function here, the sine x over x squared, I'm going to go ahead and graph that, and we've got for x values greater than 1. So sine x over x squared, and I'm going to look for x values greater than 1. So here's my image. I'm going to zoom in a bunch. Let's see here. Let's come back this way. And then go this way a whole bunch. Okay, so I can see that my function is oscillating, of course, because it's a sine function. And if I was going to integrate this, then I would have a negative bit, a positive bit, positive bit, negative, positive, etc. So now if I look at the absolute value of that, and again for x greater than 1, if I integrated this, I would have positive, 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 etc. So obviously, if this integral is convergent from 1 to infinity, this integral is going to be less than if I go underneath the x-axis, or equal to if it was all positive. So looking at sine x over x squared, well, an obvious comparison would be comparing it to 1 over x squared. And I can see that for sure my absolute value, I know that sine x oscillates between -1 and 1. So if it's absolute value, it's oscillating between 0 and 1. So it's always going to be less than or equal to 1 over x squared. So coming back here, I can say that my 0 is less than absolute value of sine x over x squared, which is less than 1 over x squared. I know that the integral from 1 to infinity of 1 over x squared converges by p-test. Therefore, my integral from 1 to infinity of the absolute value is convergent. So straight away, I can say that this implies integral of 1 to infinity sine x over x squared is absolutely convergent. And again, that's because of comparison. So I know that this integral is less than this integral. X squared dx. Because this includes negative values, this is fully positive. But as soon as I know this, I can straight away say absolutely convergent.